2, 6, 4, 10. Same model, only the nth term it is different. Find the number of trailing zeros. The series is given in arithmetic progression. Step number 1. Tn equivalent to a plus n minus 1 into d. 2 plus n minus 1 into 4. So this will be 4n minus 2. Check it out whether 4n minus 2 is the nth term. N value 1, 4 minus 2, 2, n value 2, 8 minus 2, 6, n value 3, 12 minus 2, 10. Tn is 4n minus 2. Step number 2. N value can range from 1 to 125, 4s are 500 minus 2, 498, 126, 4s are 504 minus 2, 126. N value can range from 1 to 126. Step 2. 4n minus 2 is equivalent to 5a. I am sure you can solve this equation same like that. Step number 2. 4n minus 2 equivalent to 25b. Step number 3. 4n minus 2 equivalent to 125c. 625 we cannot take. 625 we cannot take. 3 problems, same model, so that it will be clear to you. 4n equivalent to 5a plus 2. 4n equivalent to 4a plus a plus 2. Divisible by 4, divisible by 4. A minimum, it is 2. 2 plus 2, 4. It is divisible by 4. 5 2s are 10. So this will be 10 plus LCM of 4 comma 5 into k. K can be 0, 24. Why it cannot be 25? 20 into 25, 500. 500 plus 10 is 510. Upper limit is 502. 0 to 24. Second case, 4n equivalent to 25b plus 2. 4n equivalent to 24b plus b plus 2. Divisible by 4, divisible by 4. B minimum will be 2. So it is 50 plus LCM of 4 comma 25 into k. K will be 0 to 100. 5s are 500. 500 plus 50. 550. 0 to 4. 4n equivalent to 125c plus 2. So this will become 124 plus c plus 2. Divisible by 4, divisible by 4. C minimum should be 2. So 2 plus LCM of 4 comma 125 into k. K can be 0 or 1. 0, 1, there are 2 values. 0 to 4, there are 5 values. 0 to 24, there are 25 values. Idea clear? I hope the idea it is clear. Idea it is clear. These are some of the very, very good questions. You are going to learn some wonderful questions in trailing zeros session number 2. Tn equivalent to a plus n minus 1 into d. First, the entire centralized idea is power of 5 is less than power of 2. That is the reason I am just checking the powers of 5. 5a, 25b, 125c. Remaining it is 625. Upper limit is 502. Good questions. Please try to solve it. See this question, sir. See this question. Find the number of trailing zeros. I want the number of zeros at the end. In the multiplication of these also we discussed in session number 1. 201 into 202 into 203 and so on up to 300. 201 into 202 into 203 till 300. If the question is not in factorial, I need to make it into factorial. How to make it into factorial? Multiply the numerator and denominator by 1 to 200. So this will become 201, 202 till 300. Denominator will be 1 into 2 into 3 till 200. So this answer will be 300 factorial divided by 200 factorial. Factorial number of zeros at the end is dependent on the power of 5. So 5 60s are, 5 12s are, and 5 2s are 74. So the numerator it is 5 power 74 into K1. Denominator it will be 5 40s are, 5 8s are, 5 1s are. It is 5 power 49 into K2. 74 minus 49. Answer will be 25. If the question is not in factorial format, make it into factorial format. How to make it into factorial? Multiply the numerator and denominator by that number which will result in factorial in the numerator and denominator, which will result in the numerator in factorial in numerator and denominator. Very, very good question. I hope you understood how to solve the problems if the factorials are not given. Next one, another question. Oh, these also a level 3 question, sir. Already we discussed it. Let me write down that key point. What are the key points that we discussed? We discussed it in session number 1. Session number 1. 1 factorial till 4 factorial. Number of trailing zeros. Number of trailing zeros. 1 factorial to 4 factorial. There will be no 5s. So number of trailing zeros will be 0. Number of trailing zeros will be 0. Similarly, 5 factorial till 9 factorial. 5 factorial, the number of trailing zeros will be 1. The same it will be there for 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9 factorial. So 1 into 5, I will get it. Similarly, from 10 factorial till 14 factorial, 10 factorial, whatever the number of zeros are there, the same thing will be there till 14 factorial. 10, it will be 2. So it is 2 into 5. 2 into 5. 15 factorial till 19 factorial. 5 3s are 15. So the number of trailing zeros for every number will be 3. 5 numbers are there. So it is 3 into 5. 3 into 5. 20 factorial till 24 factorial. It is 4 into 5. 25 factorial till 29 factorial. 25 it is 5 square. There is a jump of 2. It is 6 into 5. 30 factorial till 34 factorial. It is 7 into 5. Next it is 35 factorial. It is 1 5 I will get. 1 5. Till here it is clear, right? So this will be 8 into 1. Only 35 factorial it is 1. Number of zeros at the end will be 8. Is this idea clear? This is what we did it. Now the question is 1 factorial into 2 factorial into 3 factorial into 4 factorial into 5 factorial till 9 factorial into 10 factorial till 14 factorial. I hope you are understanding why am I writing like this. 15 factorial till 19 factorial. 20 factorial till 24 factorial. Into 25 factorial till 29 factorial. Into 30 factorial till 34 factorial. Into 35 factorial. Whole square the question is given. Whole square the question is given. Now easily one more step you will get the answer. There are no 5s here. Out 5 factorial into 9 factorial. 1 into 5. So there are 5 5s are there. 10 factorial into 14 factorial. There are 2 5s are there. 2 5s are there, like that 5 numbers are there. 5 numbers are there. That means it is 5 square into K1, 5 square into K5. So 5 times it is added. So it is 10. I'm sorry, sir. Next one, 15 factorial till 19 factorial. How many are there? 3. So it is 3 into 5. 20 factorial, it is 4 into 5. 25 factorial, how many I got? 6 into 5. 30 factorial, it is 7 into 5. 35 factorial, it is 8 whole square. It is whole square. Now, if you see here, now if we write like this, these 5 power 1 into K1, it is 5 power 1 into K5. So how many times? From 5 factorial, it is 5 times we got. So these are all, it is 5, these are all like this. Yes or no? From 5 factorial to 9 factorial, 5 power 1 into K1, 6 factorial, 5 power 1 into K2, 9 factorial, 5 power 1 into K5. From 5 to 9, there are 5 5s are there. So this will be addition because of 5 powers. Don't do this silly mistake. That is the reason I am writing it. So it is 5 power 5 into 5 power 2 into 5 into 5 power 3 into 5 into 5 power 4 into 5 into 5 power 6 into 5 into 5 power 7 into 5 into 5 power 8 whole square. So this will be 5 power 10 plus 5, 15, 15 plus 15, 30, 30 plus 20, 50, 50 plus 30, 80, 80 plus 35, 115, 115 plus 8, 123. 5 power 123 power 2, 5 power 246. Answer will be 246. Answer will be 246. Very, very good question, sir. So even if you add it, 35, 30, these 5, this will be 10, this will be 15, this will be 20, these 30, these 35. If you add it, 15, 30, 50, 80, 115, 115 plus 8, 123. Square is there, I will get 246. Instead of doing all this, just I wrote it like this. You can add all this. You have understood how to do this function, right? Once you understand this one, it is very, very easy, sir. Very, very easy. These kind of questions are coming regularly in your examinations. Why it is added? Because power functions, a power m into a power n is a power m plus n. A power m plus n. Suppose if the question is like this, 5 factorial into 6 factorial and so on up to 24 factorial power 3. Number of trailing zeros. How to write down the answer directly? Number of trailing zeros. Number of trailing zeros. 5 factorial into 6 factorial and so on up to 24 factorial power 3. Find the number of trailing zeros. Right, now see here, from 5 factorial till 9 factorial, there are 5 numbers are there. Each number will give one highest power of 5. Similarly, 10 factorial till 14 factorial, it is 2 into 5. You don't need to do anything. 5 into 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. Into the power. Simple. This is the answer. Because 15 factorial till 19 factorial. 15 factorial contains 3 powers of 5. 3 into 5. Next will be 20 factorial into and so on up to 24 factorial. I will get 4 into 5. So if I add it, 5 common, 1 plus 2 plus 3 plus 4. A power n will become m into n. 7 and 9, 10. 10 5s are 50. 50 3s are 150. How many trailing zeros will be there for this expansion? it is 150. Even it is not difficult, just with a little practice, you can solve it very, very easily. 65 factorial into 66 factorial and so on up to 80 factorial power 4. 65 factorial into 66 factorial and so on up to 80 factorial power 4. Number of trailing zeros. Number of trailing zeros. Let us find it out easily without doing step by step like in the previous problem. 65 factorial into 66 factorial and so on up to 80 factorial. First we will do 65 to 69. So 65, how many zeros are there? 65 will be 5 13s are, 5 2s are. It is 15 into 5. This will be 16 into 5. This will be 18 into 5. This will be 19. So answer will be 15 into 5 plus 16 into 5 plus 18 into 5 plus 19. I hope the idea it is clear. Don't do any silly mistakes. Avoid doing any silly mistakes. First find out the number of zeros at the end for factorial. 5 13s are, 5 2s are. 13 plus 2, 15. 65 will have 15. 66, 67, 68, 69. 15 into 5. Next multiple, extra 1 will come. 16 into 5. 70 to 75. 75 is a multiple of 25. Extra 2 will come. So 18 into 5. 80, it is 19. Similarly, if the question is 124 factorial till 130 factorial power 2. Power 2. It is this one and it is power 4. So into 4. Into 4. I hope you are understanding the logic. Idea is to reduce the number of steps. Idea is to reduce the number of steps. So anyway, answer will be, it is into 12. 124 factorial. 5 24s are. 5 4s are. 24 plus 4, it is 28. First one 28 I will get. 125. 125 is 5 cube. Extra 3 will come. That means 31. How many numbers it will come? 125, 126, 127, 128, 129. Into 5. Plus 1 more will come, 32. I hope this answer it is clear. Is the answer clear? For 124 factorial, I will get 28 zeros at the end. 125 factorial. 125 will be 5 25s are, 5 5s are, 5 1s are. It is 31. 125 to 129, it is 31. Plus 130, it is 32. 28 plus 31 into 5 plus 32. Idea clear? Very, very easy question, sir. From 5 factorial till 9 factorial. It is 5, it is 6 and it is from 5 factorial till 9. It is 5 into 1. Extra 1 more will come. Extra 1 more will come. 2 into 5. Extra 1 more will come. Extra 1 more will come. But from 25, extra 2 will come. Are you all with me? I hope the idea it is clear. Idea, I hope it is clear. Let me do one more question. Mock created question, sir. 90 factorial into 91 factorial and so on up to 100 factorial power 12 divided by 70 factorial and so on up to 80 factorial power 10. How many trailing zeros are there for these number? Find the number of zeros at the end. Zeros at the end is called as trailing zeros. 90 factorial into 91 factorial and so on up to 100 factorial. We will do slowly, sir. First 90 factorial till 94 factorial. Step number 1. We will do it for the smallest number. 5 18s are 90. 5 3s are 15. 18 plus 3, 21. So I will get 21. For 90, I will get 91, I will get 92, I will get 93, I will get 94, I will get. Then 95, there will be extra 1. 22 into 5. Are you all with me? Plus 100. 100 will be the 25 into 4. Extra 24 will come. This is into 12. This is number of zeros at the end. 10 power k will give you the number of zeros. 10 power. Similarly, the next one. These are, most of the students will leave these questions, but actually they are very easy questions. 70 factorial to 74 factorial. 70 it will be 5 14s are, and next one it is 2s are. So this will be 16 into 5. 70 to 74. 75 is a multiple of 25. So 18 into 5. 80. 80 will be one more than. It is 19 into 10. Into 10. So this will be 105. This will be 110. This will be 24. These 215 plus 24. 239. And this will be, so 10 power 239 into 12 minus 16 5s are 80, 18 5s are 90, plus 9, 170 plus 19, 189, 189 into 10, 1890. Whatever the answer that you will get here, that will be the number of zeros. I hope the idea it is clear. The more and more questions you will solve under this variety, the more and more concepts you will find it beautiful. Very easily you can solve. Why it is 21 into 5? 92, 94. Why it is 22 into 5? 95 to 99. What it is? 100 factorial. Similarly, these 70 to 74, 75 to 79, and this will be 80. A power n is a power m into n. A power m into n. Good question. I hope you enjoyed solving these beautiful